Diffusion becomes dramatically slower as distance increases. Double the distance and transport doesn't merely take twice as long. It becomes much, much slower. Increase the size of an organism by 1,000 times, and molecules suddenly require millions of times longer to travel the same relative distance. At microscopic scales, that's manageable. At human scales, it's impossible. If your body relied only on diffusion, oxygen would take years to reach some of your cells. You wouldn't survive for more than a few moments. That's why large animals evolved entirely new delivery systems: hearts, blood vessels, capillaries. Complex networks that transport oxygen, nutrients, hormones, and waste products throughout the body every second of every day. Those systems are exactly what make large, active animals possible. Ironically, they're also the very systems that prevent us from ever evolving wheels. By now, it might seem like we've uncovered every reason evolution avoided the wheel. The plumbing doesn't work, the wheel can't repair itself, it can't grow with the rest of the body. Large animals depend on circulatory systems that make continuous rotation impossible. But let's ignore every one of those obstacles. Imagine an animal that somehow solves them all. It evolves a living socket that never twists. It grows a durable wheel that continually renews itself. Its nerves and blood supply function perfectly, no matter how fast the wheel spins. Surely that creature would dominate its environment. Surprisingly, it probably wouldn't, because a wheel by itself isn't actually a complete way to move. It's only half of a transportation system. The other half is the surface beneath it. Think about one of humanity's greatest engineering achievements, the railroad. Steel train wheels rolling on smooth steel rails are astonishingly efficient. Once a train is moving, very little energy is needed to keep thousands of tons of cargo traveling across long distances. It's one of the most efficient transportation systems ever created. Now imagine taking that exact same train and removing the tracks. Place those steel wheels on loose sand, soft mud, rocky ground, or a forest floor. Almost immediately, they sink, bounce, or get stuck. The wheels haven't changed, the terrain has. That's the hidden weakness of every wheel. A wheel touches the ground continuously. It has no choice but to follow every bump, hole, rock, and obstacle directly in its path. A leg works completely differently. Instead of rolling over everything, a leg chooses exactly where to land. It can step over rocks, it can avoid holes, it can climb onto ledges, it can cross streams, push through dense vegetation, and navigate rough terrain with remarkable flexibility. Every step is a new decision. Every foot placement can adapt to changing conditions. That adaptability is incredibly valuable in nature. And for most of Earth's history, the planet offered very little smooth ground. Long before humans existed, landscapes were covered in forests, wetlands, loose sand, rivers, mountains, roots, fallen branches, and uneven rock. There were no highways, no paved streets, no concrete sidewalks, no carefully engineered roads. The environments that shaped evolution were chaotic and unpredictable. In a world like that, legs almost always outperform wheels. Humans eventually changed the equation. We built roads, we flattened landscapes, we constructed bridges and railways that allowed wheels to perform at their best. In other words, we didn't evolve to match the wheel. We reshaped the environment to suit it. History illustrates this perfectly. One of the oldest known engineered pathways is called the Sweet Track, a wooden walkway built across marshland in what is now England. Tree ring dating shows it was constructed around 3807 BC. Interestingly, it wasn't built for carts. It was built for people walking on foot. Even some of humanity's earliest roads were designed for legs rather than wheels. Only later did civilizations begin creating smoother, wider roads capable of supporting wheeled vehicles. Nature never had that opportunity. Evolution couldn't pave the planet. It had to work with the terrain that already existed. And in that world, legs remained the superior solution. But there is one final obstacle, and in many ways it's the most important of all, even if wheels were biologically possible. Even if the environment favored them, evolution still wouldn't know how to build one. That's because evolution doesn't plan for the future. It has no blueprint, no goal, no grand design waiting at the finish line. Natural selection works only in the present. Every small change must provide an immediate advantage. If a mutation helps an organism survive or reproduce today, it's more likely to spread. If it makes survival even slightly harder, that mutation usually disappears from the population. Evolution cannot sacrifice today's success for tomorrow's reward. It has no ability to think ahead. Imagine the earliest stages of an eye. A tiny patch of light-sensitive cells can already tell the difference between day and night. That's useful immediately. A slightly deeper depression helps detect the direction light is coming from. That's even better. Over countless generations, each small improvement provides another advantage until eventually a complex eye emerges. Every step along the journey is beneficial. Now compare that to a wheel. What would the first stage even look like? A rounded bump sticking out from the side of an animal. It doesn't roll. It doesn't improve movement. It simply costs energy to grow while getting caught on branches, rocks, and vegetation. That animal is worse off than its competitors. Natural selection removes it long before the structure can evolve into anything useful. Every possible intermediate stage suffers the same problem. A quarter of a wheel isn't helpful. Half a wheel isn't helpful. Even something that almost resembles a wheel still provides little or no benefit unless the entire rotating system is already complete. And evolution rarely rewards unfinished projects. Biologists have described this challenge using the idea of an adaptive landscape. Imagine a vast mountain range. Each peak represents an effective biological solution. Each valley represents designs that reduce survival. Evolution naturally climbs uphill because every successful mutation offers a small improvement. But it almost never crosses deep valleys where organisms become less fit along the way. The wheel appears to sit on one of those isolated peaks. Reaching it would require passing through many generations of less successful designs. Natural selection simply doesn't allow that journey. It's like trying to leap across a canyon one small step at a time. No matter how desirable the destination may be, the path leading there doesn't exist. And that's why after billions of years of experimentation, evolution still hasn't produced an animal with true wheels. Not because wheels are a bad invention, but because the route to building one is blocked at every stage. Once you understand that idea, you begin to notice something fascinating. The wheel isn't the only invention missing from nature. There are several technologies that never evolved, even after billions of years of experimentation. No organism has ever learned to create and control fire. No species has naturally smelted metal from ore. No living thing has evolved a radio or built a machine capable of transmitting information across the air using electromagnetic waves. At first, those examples seem completely unrelated, but they all share one critical feature. None of them provide an immediate benefit during their earliest stages. A tiny spark that immediately burns out isn't useful. A partially melted rock is still just a rock. A half-built radio doesn't communicate with anything. Each of these inventions only becomes valuable after several separate components are assembled into one complete system. And that's exactly the kind of challenge evolution struggles with. Natural selection can't work toward a distant goal. It only rewards changes that improve survival right now. Every generation must be slightly better than the one before it. There is no planning, no blueprint, no designer looking ahead. Every successful adaptation is built one small improvement at a time. That's why the absence of wheels isn't a flaw in evolution. It's evidence of how evolution actually works. In many ways, the missing wheel is like a fingerprint left behind by natural selection itself. It reveals the limits of a process that can only move forward through tiny, useful steps. And when you think about what evolution has accomplished despite those limits, the result is astonishing. Without foresight, without intention, without knowing where it was going, evolution produced eyes capable of seeing galaxies. It created wings that carried animals into the sky. It built echolocation, venom, camouflage, photosynthesis, and brains capable of understanding the universe that created them. At the microscopic level, it even invented true rotary motors billions of years before humans imagined engines. The bacterial flagellum spins like a propeller. ATP synthase rotates inside nearly every one of your cells, quietly producing the energy that keeps you alive every second. Nature solved the engineering challenge of continuous rotation. It simply solved it where physics made it practical at the scale of molecules instead of entire animals. That changes the question completely. The mystery isn't why evolution failed to invent the wheel. It's why the conditions that make wheels useful almost never exist for large living creatures. When you combine every obstacle together, the answer becomes clear. A wheel needs a freely rotating axle. Large bodies need nerves and blood vessels. Those systems can't twist forever. A wheel constantly wears down. Living tissue must continually repair itself. Large animals have to grow. Detached wheels can't easily grow with them. Natural landscapes are rough, uneven, and unpredictable. Legs adapt to changing terrain far better than wheels ever could. Finally, evolution cannot plan several generations into the future. Every intermediate stage has to work immediately. A wheel simply doesn't offer that gradual path. Each problem alone is difficult. Together, they make the biological wheel one of the least likely inventions evolution could ever produce. Ironically, humans solved every one of those problems not by changing ourselves, but by changing our environment. We built roads, we laid railroad tracks, we manufactured durable materials that could be repaired or replaced. Instead of evolving wheels, we created a world where wheels could thrive. Perhaps that's the greatest difference between biological evolution and human intelligence. Evolution adapts organisms to fit their environment. Humans reshape the environment to fit their inventions. That distinction may even extend far beyond Earth. Imagine intelligent life evolving on another planet. If it emerged through the same process of natural selection, it would face many of the same physical constraints. Its bodies would still need to transport energy. Its tissues would still wear down. Its adaptations would still have to evolve through countless small, beneficial steps. The details might look completely alien. Their chemistry could be different. Their appearance could be unlike anything we've imagined. But the underlying rules of evolution would remain remarkably familiar. Movement would most likely rely on structures that provide immediate advantages throughout their evolution. Legs, fins, cilia, muscular waves, or flexible appendages, not giant biological wheels. Somewhere in another solar system, at this very moment, a living creature may be crossing an open landscape beneath an unfamiliar sky. Its world may orbit a different kind of star. Its biology may be built from molecules we've never encountered. Its senses might perceive reality in ways we can't even imagine. Yet, if life there followed the same evolutionary principles that shaped every organism on Earth, that creature is probably not rolling. It's almost certainly walking, and perhaps that's the most remarkable lesson of all. Sometimes, what evolution never creates tells us just as much as everything it does.